Good morning, students. In last classes, we have discussed about the density and the relative density and also the process to measure the density of solids as well as liquids. Now today we will start our lesson with the comparison of densities between solid, liquid and gas. Now remember the first chapter where you learned about the properties of solid, liquid and gas by kinetic theory. There we learned that for solids the intermolecular attraction is so high that there is almost no space between the molecules. So the molecules are tightly packed, where in liquids the intermolecular attraction is less than solids but greater than gases, and for gases the intermolecular attraction is least. That is why gases doesn't have any definite volume or shape. Now if you come to density, then also we know that density is directly related to mass. So if for solids the molecules are hardly or strongly packed, then the mass of the solid will also be greater compared to liquid and gases. That is why the density of solid is obviously greater than liquids. Again, for the same cause, the density of liquids is greater than density of gases. And as the molecular space is maximum for gases, so you can say gases are least dense. So you can take it as another comparison between solid, liquid, gas according to their densities. Now let us discuss some different factors. It is sinking and floating. All of you have seen that some materials, some elements sinks in water, some doesn't, some floats. And there are some elements or materials which only floats in water or any liquid by submerged some part of it. Now why this happens? This is directly related to the relative density of the material. If I say that relative density is greater than 1, that means what? The density of that element or substance is greater than the density of water. That means it is heavier than water, so it will sink in water. Now if relative density is less than 1, that means the element or substance is lighter than water because its density is less than water, so it will float on water. This is the simple concept. Whether a body will float or sink, you can easily judge from its density, as if you know the density of water. Now there is a law on which this flotation works. Now think of an example. Suppose you kept some water in a bucket. Suppose the bucket is totally filled, and now you are immersing a body of, suppose, a ball in that bucket. Then what will happen? Some amount of water will displaced from the bucket or will overflow. Now this displaced water has an importance. From this a law is developed, that is Archimedes principle. Now here we won't discuss about the principle in details. We will only consider on its consequence. The consequence was drawn that the weight of the floating body or the weight of the body submerged in liquid should be equal to the weight of the liquid displaced. Okay, so when you are immersing a body or dipping a body in liquid, then some amount of liquid will be displaced, and that weight of displaced liquid is equal to the weight of the body submerged. This is the simple concept or simply law of flotation. Now question is, what are the forces that acts on a body when a body is immersed in a liquid? Very simple. We all know that first of all the weight of the body will be there, and weight should always act downward, as we learned earlier. In our notation we will denote weight by W, and there is another force, a new force that will be developed when the body is immersed in liquid. That force is called buoyant force. Buoyant force is nothing but the upthrust produced by liquid on the body. So when you are immersing or dipping a body in liquid or water, then water will apply some upward force on the body to push it outside. That force is buoyant force, and in our notation we will consider two forces or buoyant force as F suffix B. So these are the two forces that acts on a body when it is immersed in a liquid. One is the weight of the body and second one is the buoyant force. So for this class, up to this you will read, you will prepare the theory or the concepts very clearly. In our next class we will discuss the application of this law of flotation or some examples of flotation or how flotation depends on density. These whole concepts we will discuss in our next class, but to understand that, first you have to learn these parts or these things which we discussed today very clearly. So read this theory very carefully and be prepared. We will discuss further in the next class. Thank you.